Welcome to Programming Rainbow. In this video, we will continue on the series of Conway's Game of Life written in C and SDL2. So if you want to follow along with this video, you can go to github.com, Programming Rainbow, and this one will be called Conway's Game of Life, C, SDL2. You can clone this repository, you can move inside the directory. I just want to show you the final project real quick, just so you can get an idea what this looks like. I'm just going to compile the final code that's in video 6. So this is Conway's Game of Life. You can look it up if you don't know what it is, but it's this idea that there are 4 rules and they decide whether a cell lives or dies. And then you can make these incredibly complicated structures. You can make gliders. You can make interesting artwork. You can even make things like OR gates, AND gates, computers. You can do all kinds of, it's kind of like your imagination is the limit. So this is just random and I can speed it up. I can slow it down. I can clear it. I can reset it to a random. I can pause it. I can click on it and edit the screen. So I can remove these or add it back if I want. I could put one here. Okay, so you can look up what Conway's Game of Life is. Wikipedia, and there's a whole bunch of pages and everything else. It is a very interesting thing. I just want to show you it working. And I have a display here where it's paused or what speed it is and so on and so forth. So that is the final project. Now this is the 5th video. We're going to be I'm going to show you the code real quick from the last video. And if you did just clone this repository, what's in the source directory, this will be your final project. It will be video 6. But since I'm continuing on from the last video, video 4, what's in source right here now is from our video 4. So you would want to possibly delete this directory and copy video 4 and rename it to SRC so you can follow along with where we are. Okay, so I'm just building, this is the code from video 4. Now we have no display up here and we can't speed it up or slow it down. So it's just running at a constant speed. We can, however, pause it. We can clear it. We can reset it and we can edit the board. Okay. So in this video, we're going to be dealing with the timing, being able to speed up the game, slow down the game. Basically, we're going to control how much frame time each one lasts. We can decrease it to speed up the game or increase it. And that's kind of everything that we're going to be doing in this video. I also covered that I noticed when I was looking over my code that I had set the board draw to const. So if we go in here, the board draw, since it never needs to change anything, it's set to const, so it can't accidentally change something. So in game, it's the same idea. I'm just drawing things. I don't need to change anything. I didn't have this set to const. So I have changed this to const, and then down here in the implementation, right here, I've changed this to const. So that's just one little thing that I changed. That's just so if I accidentally do anything in here that tries to mutate something, I'll immediately know about it, because when I'm drawing it, I do not need to change anything. So there's no need to. This wasn't in my video before, but however, it was on GitHub, but I just want to show this real quick. For anybody who's on Mac OS, if you installed SDL2 through Brew, I've just added this. And again, this has been on the GitHub the entire time. What I've done here is I've added an entry for Clang D. So right here, you can see when I'm looking at this, I have an LSP running, which is Clang D. Even though I'm compiling with GCC, my LSP is actually Clang. So this is going to tell Clang D where to find the include the header file. So that Clang can still work on Mac OS. So it's just basically adding this include directory, which is the opt homebrew include. And this is going to let the LSP find where your header files are so it doesn't tell you a bunch of errors. So this is for people on Mac OS. It doesn't affect anybody else. It's just adding another search path, basically. This just allows the LSP to work. However, it'll still compile on Mac OS whether this is here or not, because my makefile is using package config. So assuming you have package config, if you don't, the makefile fails and tells you that you don't have package config available. But if you do, this is going to take care of finding it for you, assuming you don't have just a completely broken system, or if it is in a proper search path. This is going to work across Linux and Mac, possibly Windows. I have carved out some code here for Windows, but I actually do not 100% know if it does. So I'm attempting, but I don't know if it does. So that's just real quick. These things were already in place. I'm not adding them now. They may not have showed up in my video down here, but they were already on GitHub because I had already been testing this to make sure it does compile across Linux and Mac. This video, we're going to be adding a new FPS C and H file that has a struct in it that we're going to be putting on the heap. So it's kind of our object thing, and it has functions for it. When we are doing game, we are kind of just printing out that the whole game is cleaned. But I kind of was lazy. Let me just grab this real quick. And I didn't put it in board, and I kind of just like to see this for my own visual thing to know that this was called, like when it's closing. This is completely unnecessary. This is just for me visually to see that it is shutting down the way I want it to. So I'm going to add one in here as well. And I'm going to add it into the FPS when we make it too. So I'm going to say that one is all clean. And this one will say board clean. Board clean or clean board. Doesn't really matter. So I've put this little message down here just so I can visually see that this is being cleaned. The other thing, it's just so I know that this is running. It's just a little thing for me. You don't need to put this in. So we're going to create an FPS one that's just like this. That is kind of like our little C style object, not quite class thing, where we have our struct and our functions. Okay, so I'm going to create two files called FPS C and FPS.h. So we got the if and def, and this will be FPS.h. Oops, it fixed it for me. That's nice. My LSP actually fixed that H for me. And then the end if. So I'm going to include main. And now I'm going to just make a struct, and it's going to be holding on to the stuff that I need for timing the game. I'm going to kind of just put some stuff in this struct, and then they'll make more sense along the way, but I'll try to explain them. So normally I use this FPS to time games so I can make them run at using delta time, and I can make them run no matter if they speed up or slow down. I can make all the game movement work the same. I'm not going to do that in this one. That's not what I'm using this FPS for here. Although I'm using much of the exact same code, I'm actually just using this to vary how much the game loop takes, so I can slow it down and speed it up. So this is actually kind of a different idea. And so when you slow it way down to like maybe when you're getting closer to the 1 second for the game loop, when you go to click something, you may have to wait like a second for it to update. It'll still update, but it's like I'm actually making the game time way slower. But it's fine. This is a simple project. I'm going to be getting time with get ticks from SDL. And the function is right here. This is the only new function that we're going to be looking at. This just gets how many ticks has passed, I believe, since the program started. And there is a rollover thing. After 49 days, this could roll over. I'm going to take care of that. But this is getting ticks, and this is in milliseconds. So it's going to return a uint32, which is just an unsigned 32-bit integer. In milliseconds, how many ticks has passed since like the program has started. So I'm going to use this to get like, what's the current time? What's the current time again, to see how much time has passed. So this is the only new function. And we don't need to include this. It's already part of SDL, so it's fine. So just understanding that, I'm going to be using this uint32. So I'm going to have something called last time, which is at the bottom of my game loop. I'm going to mark that time. So when I go through the game loop again, to see if I need to delay it to make the game frame a certain amount of time, I am going to be using that to see how much time has passed. So I'm going to be keeping track of the very end of my game loop's time. So here's the game loop right here. And I'm going to be keeping track of this time right here. This is going to be last time. Okay. And right up here, I'm going to grab the time with get ticks to find out if this whole game loop is going to be my target duration Like I want it to be, say, 16 milliseconds. I want that this I'm targeting 16 milliseconds. I can take the last time. I can grab the loop starts again. It does all my logic, draws, and stuff, and then I can use get ticks right here to grab the current time, subtract the last time from the current time. That gets my time that has passed, and then I can subtract that from my target duration if I wanted to. So say the time that went by was 1 millisecond and I'm targeting 16, I could say, well, I want 16, but 1 millisecond's gone past. So I can take my target duration 16, I could subtract 1 from it. I got 15, and then I can tell my delay to now delay for 15. So I'm going to grab the time here. I'm going to look at this last time and find out what's passed and what's my target. And I'm going to calculate what the delay needs to be. I'm going to delay it. And then I'm going to grab the time again and find out where I was. And that time that I grab after the delay will eventually become last time again. So when we go through the loop again, hopefully this kind of will start to make more sense as we do it. But for this game, I'm actually just using it to slow and speed up the game. I'm not using delta time. I'm just going to lock the game to the frame time, and I'm just going to slow the frame time down to slow the game down, and then speed up the frame time to speed up the game. So this is kind of different than any other time I would use FPS, but it works for this. So this is going to be UN32, and this UN32 is defined by SDL. Last time, and then I'm going to need, I called it target delay, but I'm going to call it target duration because that makes more sense because it's the target that I want the entire frame to last. And this is going to be a double. So I calculate what my delay is, then I actually delay, and then I check the time again. And when I check the time again, I see if I was off on that target. So let's say I was targeting 16, and after my delay, I actually took 17 milliseconds, not 16. I'm actually going to carry this delay over that's off. In the next frame, if I'm targeting 16, I'm actually going to target 15 instead. I'm going to say my target duration is 16, but my last delay took too long and I want to shave a little off of this one. So I'm going to target 15 to get back on track. But this amount that I can edit how much my duration is, I want to limit this because what would happen is if my game is running fine in a normal game using delta time, if my game was running fine and then suddenly my game froze for like a minute, after it unfroze, my game would just run at max speed for a while and be running too fast, trying to catch up until it could wipe out how much carry delay there was. So what I'm going to do is I'm just going to allow a little bit of movement, which is going to be 50 milliseconds worth. So I'm going to call that's going to be how much of the carry delay. It's going to clamp how much carry delay I can have. So I'm going to call this max delay and carry delay. So these are going to be doubles. So carry. This is it. Carry delay is, like I said, if I missed my target, you'll never hit your target exactly. Also, my target duration is going to be something like 16.66666, right? It could be, depending on how the game is run. And I can only target 16 because that's an unsigned integer. So I can carry that 0.6 over as well. So this kind of allows that. So this one is going to be clamping it. So I only go plus or minus 50 milliseconds. And these can be const as well. Max delay. I'm going to just add in, it's not really important for this program, but I'm just going to add in an FPS counter. So that means I need to keep track of the FPS last time separately because it's going to be its own logic. So it's going to be another UN32, and I'm going to call it FPS last time. These are the same, except this one, well, they're not the same number, but they're the same idea. I'm doing the same thing. This is the last time for the FPS function. And we'll just call this FPS counter. And then I'm going to have a Boolean where I can turn on the FPS counter or not, to display the FPS. So I'll call it display. Now, right away, I know I'm going to have an FPS new to put this on the heap, an FPS free to clean it. I'm going to have a toggle to turn on my FPS or not to switch this bool right here. And I'm going to have an update, which is going to be timing the game. I'm going to call it FPS update, but it's going to be the thing that checks my time, updates my FPS last time, and causes the delay and everything else. So I'm just going to create those right now. And the only one that can fail is my new, because that's the one running the calc. And I'm going to check to see if that failed or not. The other ones, I'm just mutating numbers and they're not really going to fail. So this is going to look just the way it did when I did the game and I did the board. This is the exact same idea. So I'm going to have FPS is a pointer to an FPS struct. And it's for the same reason. And free is the same. Now the toggle and the update, they're just using F as a pointer to FPS struct. This will be the update. Okay, this will be the entire FPS struct and all the functions that are dealing with it. There will be one other function, but it's not, it doesn't need to be seen outside of this kind of module. That is just checking rollover and stuff. It'll be in the implementation, it'll be in the C file, but these ones need to be actually called it from games. So the new, the free, the toggle, and the update need to all be called from games. So they need to be seen outside of the C file. So right away, we need to include the FPS. So I am going to have this other function, and the reason why is because I need to use the SDL get ticks to check the time 3 times. Let me just look at the game loop again real quick. So imagine when we go through the game loop, I have the time down here, right? I come up, do all the logics, some time is going by. I check my time here. That's one time I need to check the time. And I need to check for rollover and everything else. I need to compare it to what the last FPS time was. So I'm checking it here. And then I'm calculating out how much delay I want. So that delay happens, but then I need to check it here and I need to make sure this hasn't rolled over again. And I need to also be able to update this time that I just got here. That's going to be my new last time. That's going to be the new timestamp at the end of this thing. And this is where I decide how much carry and everything else has happened. So I've just checked it twice. But remember, I also have this this show FPS, this display FPS that's keeping track of the frames that are actually taking place separately. That has its own logic that it needs to check its time separately. It's doing its logic separately. It's not tied to that. So that's going to do it. So that's 3 times that I need to check the FPS and sorry, not check the. I need to check the ticks and be able to calculate how much time has passed. And I also need to make sure it hasn't rolled over too. And one of those 3 times, I need to update the last time to that time. So one of the times I need to update the last time, the other 2 I don't, but I always need to check for rollover. So I'm going to make a helper function basically that is just getting the ticks, getting the current time, checking it against the last time, getting what the duration was, and maybe updating. Yeah, there will be this, and it's going to return a UN32 because what this function is doing is getting the delta, the time that has passed from my last time to my current time. I need to know how much time has passed. So I'll call this FPS time since. I'm taking in the same thing twice, possibly. What the second one is doing is it's just there to set it to the new. So if I'm going to pass in last time to this function, or it could be the FPS last time, depending on how I'm using it, but I'm going to pass in last time. And the second time I do get the current time, I actually need to reset the last time to this new current time. So this first one here is this UN32. That's last time that I'm passing in, right? However, just one of these times, I actually need to set last time. I need to set it to the new current time that I just got inside this function, but it only happens one time. That means I would need to pass in the address of it. So I'm going to do this. uint 32, and I'm going to call this new last time. So basically, I'm going to put in last time in both of these. If it's in here, this is going to be able to set that inside this function to the, the thing outside of it. We'll see it here in a second. So that's going to be my little helper function. Let's do the new, the free, and the toggle, because those are just simple things, and we've seen these many times before. So let's just do that. So new is going to return whether this failed or not. And this is a struct. This is the FPS, is a pointer to an FPS struct. That's so we can edit that we're able to mutate the actual pointer that we were passing into it. And we dereference it and we say FPS equals calloc. And this is going to be the size of struct FPS. And we've seen this several times already. Okay. And then right away, we need to check to see that this was in fact allocated. So we're checking to see if it's null, and I'm going to write it explicitly. I could do a bang asterisk FPS, but I'm going to do it explicitly. So I could do this right here, and it would be the same right there if it's not null. But I'm following along with what I did in game and board. So in those, I saw if it's null. So this is the same. And printf, and we're sending it to standard error. That's the file handler we're sending it to. And this in calloc of new FPS. Okay, so basically we're trying to calloc this. We're sending in, basically we're trying to put a pointer on the stack, but since the pointer is being sent into this function, we need a pointer to that function. And we're callocing it here, and then we're making sure it was in fact calloced. If it wasn't, we're returning false out of this function. So we have this, we created this FPS on the heap. I'm going to make an F to it the same way so I don't have to keep dereferencing FPS over and over again, because that becomes annoying. So struct So this is just allowing me to use F now instead of have to dereference it, because later on when I have to dereference it, I keep having to do this depending on what the command is, and that gets annoying. So this is just for convenience, because this is a pointer to a pointer right here, and I just want the pointer. I changed the name of target delay to target duration, but we kind of need to put this in the header file real quick for main. I'm just going to put it down here. And I'm going to put it as 128 because I'm not treating this like other games where I'm targeting 60 FPS. I'm actually treating this as how fast I want each evolution of Conway's Game of Life to run. So the default, like the middle ground, is going to be 128. And then I'm going to slow it down, to speed it up. I can go from 128 to 64 to 32 to 16 to 8. And to slow it down, I can go to 256 and 512, things like that. So I'm going to start out with 128. So I'll call it target duration. And yeah, I probably don't even need the member in the struct, because oh no, I'm going to mutate it. Yeah. So anyway, this is going to be 128 kind of by default. I always want to put the equal and the semicolon, and then I screw up my code. Make sure all these defines, you never do that. Sometimes if the things are acting funny, check and make sure you didn't put a semicolon, because I've done it many times here. Okay, so back into FPS. And so I'm just going to set that right away. So it's going to be F. It's going to be duration equals target duration. I have it here, but you could put this in the main header as well. The max delay, the thing that's clamping it. I'm just going to set it to 50. But you could break this out like we did target duration. I could put a max in there, but I always use 50, so I'm just going to leave it there. But you could do it either way. Now we have the last time. We want to actually get the current time when we did this last time. We don't want it set to 0 because we don't know how much time it's taken to start up the game and everything else. So what I want to do is just grab the time right away and set it to last time. So last time, we're going to be using that function now with the SDL get ticks. And I'm going to do the same thing on the FPS last time. Actually, since I just got the time right now these two numbers are not together, but since I just populated this right now, I could just set it. It's not really a big deal. I could say FPS last time equals, we are going to be, anytime we turn this FPS thing on, we are going to be grabbing a new SDL ticks on it anyway, but we'll see that in the logic. But I'm just going to be lazy and set it to last time. That this is just in the initialization. This is just its initial value. It's not going to be tied to that. And then we have the carry delay, and we're going to set that to 0 because we're initially starting with, we're carrying nothing over. That'll be calculated each frame. 0. Okay, I think that's everything. Let's double check the header. So we have last time, we have that, we have the carry, we have max delay. Oh, the FPS counter. Okay. Yeah, I didn't put that in there. Where? Okay. Well, it would be 0 anyway because this is Calyx. So if I had forgotten anything that I forget will be 0. But I'm gonna just explicitly set it. FPS counter and to 0. But again, it is set anyway. I want to kind of move these around, put them in order. It's last time target duration carry delay. So last time target duration carry delay. So I'm going to grab this and put it up here. I'm just kind of logically putting in order. You don't need to do this either. So last time target duration carry delay and the bool. Again, the bool will be false because of the calloc, but I'll just set it explicitly. So false is 0. So when this calloc runs, everything here will be zeroed out. So these will be null or false or 0, which is all the same. And then we just want to make sure we return true so that we know that this function. So the cleanup of this is really simple because we only need to deal with freeing the FPS itself and nothing else inside of it. So this is FPS free. And it's the same thing, a pointer to a pointer. And on this one, it's just very straightforward. First thing we're going to do is check to see if this is not a null pointer. So we're just seeing if it is something. And if it is something, we're going to free it. And then we're going to set it to null. And that's why we're sending in the pointer to the pointer. It's so we can do this right here. So this affects the member in game. FPS member in game will now be set to null. What am I doing here? This is FPS. That's crazy. Let's put a semicolon. Okay, so I'm going to put that little message here too. What was it? Clean, FPS clean. What did I do in board? Clean. Yeah, I'll just say clean FPS. So right here, and I'll just say clean FPS. Okay. And the toggle is mostly straightforward. It could almost just be a ternary, but we do need to reset the counter. So what's going to happen here is, so we've been talking about time in the game, but the FPS counter actually doesn't care anything about time in the game. It's not going to be interested in any of that. It's going to be running its own logic. And what's going to happen is FPS is going to keep its own last time, but it's not the last time down here necessarily, although it will be set down here, but it's not set every frame. It's going to be set once. And then each time through, when it runs again, it's going to see if the last time plus 1 second, which is 1000 milliseconds, if the last time plus 1000 has been breached. If we've gone past 1000 milliseconds, then we're going to display how many frames that we counted, and we are going to reset the last time, not to a new time. We're not going to use get ticks for a new time. What we're going to do is we're going to take the last time and we're going to add 1000. So if we're going through and we're checking and we say, hey, was last time, is the current time last time plus 1000 is more than that or equal? Let's say it's 1002. So it's last time plus 1002 is the current time that's happened. I don't want to get current ticks because that's 1002 for the new FPS last time. What I want to do is I want to take the original FPS last time and I want to add 1000 to it. So I'm already 2 ticks in to the current series. So I'm still on track. I don't want to, so I'm not going to use the SDL get ticks to set the new FPS last time ever. I'm going to set it one time when I turn it on, and I'm always going to just be adding 1000 to it. And I'm going to be just counting how many frames have taken place and then resetting that each time I turn it on, or resetting it each time 1 second has passed. Hopefully that makes sense. So what we're going to do on this toggle thing is, the first thing is I actually do want to grab the current time. That's going to be my new last time because I want to go 1 second past this current time when I stop counting frames. So I need to grab this current time with get ticks. And I also need to set the counter to 0. So void, and this is going to be FPS toggle, display toggle. Yeah, it fixed it for me. Oops. What? Come on. That's because I typed I, yeah. We could have just done with this a ternary to flip the Boolean, but we need to reset those two things. So it's going to be an if statement. So if FPS display toggle, if this is true, we just need to set it to false. This is wrong. This is supposed to be display. And this is going to be equal to false. So if it is true, we are going to turn it on. I mean, if it's true here, we're disabling it. But if it was false here, we're going to turn it on. True. So FPS is set to true. And then we need to reset the counter is 0. And the FPS FPS last time is going to be equal to SDL get ticks, because we need to get the time right now, because we're interested in from right now to 1 second from now. So we need to get the SDL and ticks right now. Okay, so that's why we can't just use a simple ternary, because we need to set these two right here. This is whenever we turn this on. Assuming it hasn't been on, when we turn it on, we got to make sure our counter is zeroed out, and we need to grab the time from right now. And then once this is turned on, we're going to be looking for each frame. We're going to add 1 to the counter, and then we're looking to see if a second has passed. If a second has passed, we're going to print that out. We're going to reset the counter and add 1000 to the last time. We're not going to do the get ticks again. We're just going to add 1000. Okay, so that is all of the kind of simple functions. Let's look at the helper right now, the time since. The UN32 FPS time since. And this is taking the last time and then a pointer to new last time. The first thing we need to do is get the current time. So this helper function is just looking for how much time has passed since the last time. So the first thing we need to do is this uint 32, current time. And this is going to be SDL get ticks. We also need to create an elapsed time. This is what's going to be returned out of this function, but we're going to be setting it two different places. So I'm just going to create it here. This is what we're targeting. What we want the answer to is how much time has elapsed. So I'm going to initially set it to 0. We have a problem. We need to find out if this ticks has rolled over. So this can roll over, and it's only in like 45 days. But like to code safely, I do want to take this into account that this number can roll over because it's a uint 32. So what's happening here is imagine each frame 3 nanoseconds pass. Let's just say that every time we're doing this thing, 3 nanoseconds pass, right? And let's say the maximum number of nanoseconds we can have is 10 before it rolls over. I'm just making this up right now, but let's say our uint32 can only hold 10 before it rolls over and it goes back to 0 again. That's what this unsigned integers in C, they roll over. Not signed integers, that's undefined behavior, but unsigned integers do roll over, okay? So if we have our last time that we got, last time is equal to is like 5, right? Let's say it's 5, and then our current time is 8, right? So we take our current time, we subtract the last time from it, we get 3. 3 milliseconds have passed. But what if our last time now is 8? 3 milliseconds have passed, so our current time is 1. So this is a problem. If we take current, which is 1, and we subtract last time, 8, we're going to get -7. And that's not right. -7 didn't happen. So what we can do is we can take our maximum number that we can have, which in this case is 10. We could subtract 1 from it. Sorry, we subtract 8 from it. So if this is our max time before we roll over, we could say, hey, our last time is 8. Let's subtract from our max time 8, which we're going to get 2, and then we add 1, which is our current. I'm writing it here, but I'm assuming our current time is rolled over. Our current time is 1. And so if we take our maximum minus our last time plus our current, this is going to give us our answer for if it has rolled over. So we can only use that formula when we've rolled over. So the way that we check if we rolled over is if our current time is bigger than our last time, because the time is always getting bigger. It's always getting bigger, except when it rolled over, our current time is going to be smaller. So we can just say if current time is equal or larger than last time, we haven't had a rollover. If it's the same time as our last time, or it's larger than no rollover has occurred. But if it's smaller, one has. So if our current time is smaller than last time, so if current time is smaller than last time, we've had this wraparound happen. So what we can do is we can say our elapsed time, which is defined here, is going to be the maximum time. So how can we get the maximum number out of this uint32? Well, if we take this, if we take a -1 and we cast it to a uint 32, it will wrap it. It'll take -1, but like, oh no, that is the maximum number that we can have. So that's a little trick. And I'm gonna subtract the last time. And then I'm gonna add current time. Okay. So this is on rollover. If it's a rollover, I'm taking the biggest number we can have. I'm subtracting the last time from it, and then I'm going to add the current time, and that's going to give me the correct elapsed time. If a rollover hasn't occurred, then I can just say current time minus last time. Okay. So hopefully that makes sense. So basically, we're looking to see if this rolled over. If our current time is ever smaller than our last time, we have a rollover. We take max time, we subtract last time from it, and then we add our current time. And that way we can get our elapsed time. In any normal case where it hasn't rolled over, we can just take the current time and subtract the last time from it, and we get the difference. So this is going to be our elapsed time, and we can just return the last time. But what if I put something in here that's not null? The reason why I'm setting this is because I may need to set, since I've got the get ticks here, I may be setting a new last time. So I'm going to allow that in the function so I don't have to do it separately outside of the function. So I'm going to see if this is a valid address. And then say new last time. So if that is an address, I'm going to dereference it. And I'm setting it right to current time. This is so I can use this current time to set. This is if this just happened at the very, very bottom of the loop, and I'm checking to see how much time has passed to see if I'm off. But I don't need to check the time again. This is my time at the bottom of the loop. I'm going to set it to my new last time. So if I send in my new last time here, it's going to say, yeah, let's take this current time that was done here and set it. Otherwise, I'm going to put null in here, and then this will be passed by. Okay, so this is my little helper function. That's because I need to use this like 3 times. So here's our update. This is just timing this is used just for timing the game frame. Okay, so what we want to do here is we want to use our function to see how much time has passed right away. We need to know when we call this function to update our game, how much time has elapsed so far, but we already have a helper function to find out that. So I'm going to call it elapsed. Elapsed time is going to just equal this FPS time since. And we're going to put in the last time. But we don't want to set a new last time because we're seeing how much time has passed before we're delaying. So we are not setting a new last time right now. So I'm going to put null here. Okay. So what this is in our game loop, we have a last time set that was already set down here. Now we come to our logic, and right here, in place of this, before my function is actually going to do the delay, but imagine right here, I need to find out how much time has passed to calculate what my delay is. So I'm doing it right here. So this is not setting a new last time. I'm checking it right here. Then I delay. Then I get the new last time down here. So this time I'm not getting, I just need to know how much time has passed. So that's what this is doing. This is finding elapsed time. That's why I'm putting null in here. I'm not setting a new last time. And our delay, so this is kind of like our target delay for this frame, is going to be our actual target delay plus whatever carry delay happened. So I'm just going to call this delay. Because imagine we're carrying something over. If our target delay is 16 milliseconds, but our last frame we delayed too much, we delayed for 17, I'm going to carry in like a -1 in. So the carry delay for this frame will be 15, not 16. So it'll be the 15 minus the 1 for the 16, right? But I just add it is what I do. But we'll see it that like logically that's what's happening here. So we need our delay is our actual target duration plus the carry delay. Carry delay. We need to find out how much we're going to actually delay. So we need to take our elapsed time, right? But we need to make sure our elapsed time is actually smaller than our delay. So basically, if the elapsed time is bigger than how much we want to delay, say we want to delay by 16 milliseconds, but 17 milliseconds has already passed, then we don't need to delay at all because we've already taken too much time. So this delay needs to be bigger than the elapsed time. If it's not, then what are we doing? We don't need to delay. We don't need to use SDL to delay because we've already taken too much time. So uint, now we got to calculate what our current delay is. So we're going to be taking our delay and we're going to be subtracting how much time has elapsed to get our like what we're actually going to be delaying. And I call this current delay. I guess I ran out of good names. So our current delay is going to be, this needs to be a uint32, but our delay is actually a double. So what I'm going to do is I'm going to cast the delay to a uint32. That's going to truncate it. And I'm going to subtract the elapsed time from it. So we're basically, if we, whatever the delay we wanted adjusted, how about we call this duration? This is duration. This is duration. Okay. And then this is going to be delay. Is that good? So this is kind of like this adjusted duration, you know, basically the target duration with whatever carry delay happened. This is going to be the duration for this frame. If the duration is still bigger than what time has elapsed, then we can take the duration, subtract the time that has elapsed from it. So let's say our duration is 16, the time that has elapsed has been 4. We can take our duration of 16 and we could subtract the 4 from it. We get 12, and that's going to be how much we need to delay to make this frame take 16 milliseconds. So we do that, and then we use SDL, and we've already seen this delay. And this is going to be the delay that we just calculated. Okay. So I'm not sure if I'm explaining this very well, but yeah. So basically, this is our adjusted target time for this specific delay. If we've carried anything, we need to make sure the elapsed time is actually less than how much this duration is. If it is, that means we need to delay this frame longer to make it on target. But now we are going to get the elapsed time again because now our delay has happened. But we need to say, what did we actually hit our target? And I need to update the last time as well. So I'm going to do both of those things at the same time by using this same function up here. And I'm just going to grab it and do it down here. I don't need to declare the type again because this is already in scope. But over here, I'm actually going to send in the address to the same thing. But it needs to be the address. So what this is going to do is it is using the last time, but at the end of this function up here, it is going to set this get ticks, right? So when it does when it gets the current ticks on here, that's going to become our new last time. So that's what's happening right here. This one is just using the current one to check how much elapsed time has happened, so we get our answer back. But it's the last time that we're going to be checking the time in this frame. So I'm setting it to the new last time. And I would normally have delta time here, but we don't need it in this. So what we need to do now is we need to clamp the delay. We need to figure out what the delay is and then clamp it. So we can say f carry delay. And this is going to equal duration. What the duration? Because I changed the name of it. Duration minus elapsed time. Okay. So this is giving the elapsed time after our delay has happened. After this delay has happened, we're getting our new elapsed time. So if we were targeting 16 and this thing has 17, it says, oh, 16 minus the 17, we have a -1 carry. Okay, so that is going to calculate what our carry is, but we need to make sure we clamp it. I don't want it going beyond 50 milliseconds plus or minus. So I'm just going to use some if. So if carry delay is bigger than max delay. So if it is bigger, I'm going to set f carry delay to equal f max delay. So it's just clamping it, yeah? Else if, and now I'm going to check the negative version of this. So if f carry delay is smaller than -f max, then I'm going to make f carry delay equal to -f max delay. So basically, I'm not allowing it to go out of the scope of max delay, whether it's positive or negative. It can't be bigger than 50, which is our 50 milliseconds. So if this is 60 milliseconds, it's going to set it to 50. It's going to say that's as much as you get. You don't get to go past that. If it's -55 milliseconds, it's going to be set to -50. Now we have to deal with if the FPS display is enabled. If FPS display is enabled, we need to run the logic. And I could spin this out into its own function. I might actually do that. It's just a small little thing, but just to be clean, I might spin it out. FPS update display. Because I can't call it FPS update. Update. Oops, that's not what I wanted. Display. That works. I'm going to yank this. I'm going to put it above here. In my notes, I have this as just one long function, but I can just separate it out. So to update our kind of display, the first thing we need to check is if the bool is actually there. If we are counting our frames, if FPS display is actually enabled. If it's not enabled, we don't need to do anything. And then we need to check if the elapsed time is more than 1,000. So we have the helper function to find our elapsed time right here. So it's FPS since, and this is going to be FPS last time. sorry, FPS last time. And then this is going to be null because we're not updating anything. That's just our function, but I just want to, I'm not storing this anywhere. I just want to see right away if this is bigger than 1,000. So this is checking for the FPS, the time since we've set FPS last time before, have we counted up to 1,000 milliseconds yet, or over 1,000? So I could put it equal to, larger or equal to. That would work as well. So if it is, let's print it out. I didn't actually say FPS or anything. I just printed it out. So we'll just print out with a new line, and it's just going to be the counter, the FPS counter. Okay, so that's going to print that out. And then after we've printed it out, we want to zero it out because we want to reset this. So the counter, FPS counter, is going to be 0. And then we want to add 1,000 to the last time. So we're not going to use the get ticks. We're just going to add a whole number 1,000. So if we, like I said, if this was 1,005, well, we're adding 1,000 only, so we're already 5 ticks into the next. So it's keeping us on track. So last time, and we can just say plus equals 1,000, right? Now this is what happens if we have breached 1,000, or we are equal to 1,000. Otherwise, we just need to update the frames because we're counting frames, right? Each one of these time through here is counting a frame, so we can say F, and we can say counter plus plus. So we're counting frames until we breach this. Then we are printing it out, setting it to 0, adding 1,000. Sorry, this is backwards. I use this for other games. It's not really important in this game, but anyway. So we have this helper function here. So let's just call it down here. FPS update display, and we need to pass in F. And that's all. So that is the entirety of this. I'm going to get rid of that. It doesn't need to be there. Okay, so what we need to do here is we need to put this into game, right here. I'm just going to comment this out, and below it, I'm going to say game, sorry, not game, FPS update. Like that. But we have a problem. This doesn't exist yet, which is a problem. So in game H, we need to add right here. I'm just going to put it with the board one. Struct FPS, and we need to include it here. Okay, so now we have a member, but we need to also go into game, into the new, and we need to do the same thing right here for FPS. But we do not need a render in, and this needs to be called FPS. And this is, the function is FPS. Okay, and then in our cleanup, we need to, same thing as this, we need to tell FPS to clean itself up if it's valid. So this is FPS free, and then this is just, oops. I'm just going to put them together because they're both kind of like modules. Or oh, I need to send in the address to this. Okay, so now this has been created. This is being cleaned up. And I am using it down here to time it. But it's going to run much slower because this was 16. And now it is 128 because that's what we set it to in the main.h. We set it to 128, which is almost 10 times slower. It's like 8 times slower or something like that. But let's just see what happens. And I'm going to run main clean normal. Okay. So let's speed it up and see if our thing is, it is. And we got our clean FPS, clean board, and all clean. That's nice. So right in here, we could change this to just 8 to see. See if it runs much faster. Yeah, there it is. Yeah, so definitely something's happening with our timing. We can also press F, and we should get some. Oh, that doesn't work because we didn't set it up yet. Okay, so that's something to fix. I'm just going to close this. So in our game, we just need to add a one right here. So we can just add another case, and this will be SDL, and we can just put an F here for FPS, and this will be FPS toggle, display toggle, and this is going to be G FPS, and that should be a colon, not a semicolon. And I don't know why that indentation is like that. We also need a break after this. Okay. Okay, it's running fast, and I'm pressing F now, and we should see some. Oh, okay. Sorry. This is frames per second we're getting, and this is duration. I've set duration here, not FPS. This is not like other games when I do the FPS. This is different. But anyway, that's fine. I'm going to assume it's working right, and I'm going to put this back to 128. And I'm pressing F now, and it should be a smaller number. Yeah, it's fine. It's working fine. Okay, so the last thing I want to do is be able to increase the speed or decrease the speed, and I'm going to change it a little differently from my own code. They're just little, it's just a little tiny function, but I'm going to instead put this in FPS. So I'm going to make two little functions called FPS increase speed and FPS decrease speed. Void, so FPS increase speed. Yeah, I put them as game ones, but I don't like to control FPS from game directly, so I'm not going to do that. So this one is going to be struct FPS pointed F. Okay, so these two. Why is toggle on the bottom? Oh, it's sorry, it's in the header. So these are going to be very simple. I'm just going to be basically allowing it to go down to 8 and allowing it to go up to 124. So as the number gets smaller, the game speeds up. So I'll say if F target duration. If target duration is bigger than 8, then I'm going to divide target duration by 2. So imagine target duration is 32, which is bigger than 8. I divide it by 2, I get 16. And now it's bigger than 8. I can divide it by 2 again, I can get 8. Now it's not bigger than 8 anymore. I can't divide it again. So it's going to allow me to speed up to a certain point. So F target duration is divided equal to 2. Sorry, 2. And this one is going to be very similar, but this one is going to be 1024 on the max. This is going to slow it down. So F target duration is smaller than 1024. Then I'm going to say F target duration multiplied equal to 2. Okay. So this is going to just change the target duration so the game timing is changed. Now we can go into game. So just here, I guess, I'll just add a case. SDL. And you can just say up for the up arrow key. And we'll call FPS. Oh, okay. So I made a mistake real quick. Let me go back to FPS here. And these two up here, I'm going to pull them out because they need to be in the header file because I'm calling them from game. So in here, they will be, I think they're under toggle. I think I put them here. Okay, so now I have access to them in game. So increase speed, and this will be G FPS. Whoops. Oh, because I'm pressing the wrong key. This one will be down, which will be the down arrow key. And we could say FPS decrease speed, G FPS. And this one will be break as well. Not sure why it indented it funny. It should fix it here. Okay, so now we should have our increase and decrease. So let's try that. Okay, so we're kind of going slow. I'm going to start pressing the up arrow key. Yeah, we can go very fast. And then I'm slowing it down. It's very slow. Okay, I'm going to speed it back up again. Okay, that's great. And I'm going to press F so we can see our FPS printout here. So I'm going to speed it well up. So it says we're getting about 125 frames a second. Does not really matter the frames per second. I'm just trying to speed up and slow down the game. Now I've slowed it down. I'm going to slow it all the way down. This is, I think, as slow as it goes. And it's saying I'm getting about 1 frame per second. And it will kind of delay. Like if I go to close it here, it might take 1 second for it to react because my game loop is actually running slower. But for this game, it doesn't really matter. But basically, we have a last time we're keeping track of. We have our target, what our target duration is going to be, and that's in milliseconds. We have our carry delay. This is how much we can adjust from frame to frame. And this is clamping it, our max. This is separately for counting our FPS, actually being able to display it. We have a last time, we have a counter, and we have a bool. And we've seen these before, the new, the free. The toggle is simply switching this bool on or off. And it is also zeroing out. Well, we'll see it here in a second. And we have our update. So let's go into here. These are just local functions that are not called outside of this file. So the new is everything we've seen already before. We're setting our last time to get ticks when we start this. And duration is our max, our target duration that is set in main.h. It's 128 by default. You can change it to something else if you want. And then I'm just, the carry delay is going to be set to 0. The max is 50. So for 50 milliseconds is how much maximum plus or minus. And I'm just setting this so I don't have to write this again. I'm just setting it right here to the same because these numbers will be the same initially. And the counter to 0 and is turned off. The cleanup is just simple and I added these message to it, but it's just freeing it and setting it to null. The toggle is simply toggling the Boolean, and then if it is turned on, I'm setting it to 0 and getting the new time. Increasing and decreasing speed is just changing our duration. It's going to go up to a maximum speed of 8 for our duration, and on our slow end, our maximum duration is going to end up at 1024. This is a helper function that finds out how much time has elapsed since whatever last time we put in, and it's checking for rollover. And if we did put in a last time here as a an address to it, it will update whatever our current time here is to our new last time, but it's returning the elapsed time. That's what we really want. How much time has elapsed? It's just a helper function. It's used in here and here twice. So in here, it's just used simply to find out if 1 second has passed since we've set the FPS last time before. So we're just seeing, we're using that helper function above. We're not setting anything, so we got null here, but we are putting in our FPS last time and seeing if that is bigger or equal to 1,000, meaning 1 second has passed. If it has, we're printing out our counter. We're setting our counter back to 0, and we're adding 1,000 exactly to our last time. If it hasn't, we're just adding 1 to our frame counter. So for the main delaying of the game, what's timing the game, we use that same function to find the elapsed time, and we're getting our duration for this frame by having our normal target duration and our whatever adjustment, whatever our carry delay is. Now we need to make sure that the duration that we are targeting is actually bigger than our elapsed time. If it's not bigger, then we don't need to delay the game at all because we've already taken too long. But if our duration is still bigger, we need to find out how much we need to delay it to be on track. So we're going to take our duration minus our elapsed time, and that's going to be our delay, and we're going to tell SDL to delay. Then we're getting our elapsed time again after the delay. This time we're updating the last time. It's going to be the new last time internally into this function, and we're getting our elapsed time here. And we're going to use this elapsed time to see if we were on target, if we did hit correctly or not. So we're going to take our duration up here, how much we were targeting, how much the elapsed time is, and this is going to be our carry delay, and we're clamping it so it's not too big or too small. And then right at the end, we're calling our update display, which is just this function up here. It's just counting frames for us and printing it out. Okay, so we also have we've seen this increase decrease speed here. So in the game loop, we are just using that instead of that one. And then we have added a couple here. We have added this F to toggle the FPS, to turn on or off the display of the FPS. And we have added the up. This is the up arrow key on your keyboard to speed up the game, and down to slow it down. And we have also added in here this new FPS, and also to clean up the FPS. And that is in the game H as well, right here. So that should be about everything. I hope you enjoyed that or it was educational, and I will see you in the next one. Have a good day and bye.